Hey Brandon, this is Mr. Caslin. Just wanted to follow up on a problem we were working yesterday, and I don't feel like I gave you an adequate explanation. Remember, we were looking at horizontal asymptotes, vertical asymptotes, discontinuities. Now I'm just going to call a discontinuity a hole. That's a kind of a shortcut name for it. So I don't know what your function was, but it was probably similar to this function here. When you're evaluating these functions, if you can factor and cancel first, go ahead and do that. So this is the difference of squares, x plus 3, x minus 3. And you notice that the denominator also factors. That would be what? X minus 3 and an x plus 1. Okay, by factoring you'll notice that you have common factor in the numerator and denominator that cancels. So this is the function that you end up graphing. Okay, so vertical asymptote, remember, that's the easy one. Okay, so you've got a vertical asymptote at x is equal to -1. That's what makes the denominator 0. Okay, so all the values along this line have an x value of -1. Horizontal asymptote, now what's our rule? Remember the 3 rules we talked about yesterday? In this case, the degree of the numerator equals the degree of the denominator, so you're going to take that ratio, 1/1. Okay, so your horizontal asymptote is y is equal to 1. Okay, now if you were to build an input-output table and you were going to graph this, you'd find out that it is a hyperbola. And the hyperbola is sitting in those quadrants. Well, of course, it's an asymptote. We can't touch it. So, let's see if I can draw with my pen here. Okay, now you're gonna, because you had a factor in the numerator and denominator that canceled, we're gonna look for a hole. Okay, here's the mistake we made yesterday. Is we know that the hole is the x value is +3 because the factor that canceled out, that's the value that makes it 0. Now what we can't do is we can't take 3 and plug it back into the original function because that will give us a 9 minus 6 minus 3 gives us a 0. Well, we knew that because we knew that a 3 makes this undefined. Because we have an x minus 3 in our denominator, it gives us an undefined function. So what you need to do is when you're looking for the hole, don't plug that 3 into the original function. You have to plug it into this function. Okay, plug it into the factored function. So you get 3 plus 3, which is 6. And then 3 plus 1 is 4. So when you're looking for that hole, remember the hole is based on this graph, not on the original graph. Okay, so this location is the same as 3 and 3/2. Okay, I don't know how accurately I graphed this, but 1, 2, 3, 3/2. No, that wasn't too bad. Okay, so your hole is going to be right here. It means this function lives here, it lives here, but it does not live at this instantaneous point right here. Okay, so that's the only mistake we made is when you're looking for this hole, don't plug it back into the original function. Plug it back into your factored function, and that'll give you the y value. Okay, hope you enjoyed your 2-hour delay this morning. We'll talk to you later.